Welcome to Discrete Math Academy. In the present class, I will discuss about continuity of a function at a point. In the previous lectures, we have studied set theory, function, limit of a function, and in this class, we will discuss continuity of a function at a point. So let's see what is called continuity at a point. Suppose fx is a function of single variable x. Fx is a function. Now we will say that fx is continuous. Fx is continuous. Actually, in the language of geometry, we have to say that fx is said to be a function, is said to be a continuous function at a point x equals to a if we can draw the graph of the function without picking the pen from the board in the neighborhood region of x equals to a. But in the mathematical progress, if we want to say that what is called continuity of a function fx as a point x equals to a, then we have to say that if the limit x tends to a, fx equals to f of a, then we say that fx is continuous at the point x equals to a. So, if limiting value of fx as x tends to a is equals to the functional value at the point x equals to a, then fx is said to be continuous function at the point x equals to a. Otherwise, this is discontinuous at the point x equals to a. Otherwise, we say that fx is discontinuous at the point x equals to a. So, what the possibilities to be a function discontinuity at a point x equals to a? The possibilities are this limit are not exist, this limit is not exist, or this limiting value is not equals to the functional value. Limit x tends to a, fx does not exist. Fx will be discontinuous at a point x equals to a if either limit fx as x tends to a does not exist. That means the left-sided limit not equals to the right-sided limit. And the second possibility is the limiting value. Suppose the limit exists, but the limiting value does not equals to the functional value at that point. Functional value at the point x equals to a means f of a. This limit is not equals to this, or this limit does not exist. That is, the left limit not equals to the right limit. Then the function is said to be discontinuous at x equals to a. Now we will solve some important problems I have noted here. The following questions are very important. We will solve these problems. Let's consider our first question. Suppose a function fx is defined by mod x by x for x not equals to 0 and 0 when x equals to 0. Then our question is that is the function fx continuous at the point x equals to 0 or not? This will be discussed. Suppose actually the limit x tends to 0 fx will not exist here. Let's see, limit x tends to 0 fx, limit x tends to 0 0 minus, that means left limit x tends to 0 minus fx means mod x by x, as x tends to 0 minus means x not equals to 0, that means fx equals to mod x by x. Here, as x goes to 0 from the left side of 0, that means these x are negative, so mod x will give minus x. So here we have minus 1, so this is minus 1, and the right limit x tends to 0 plus fx equals to limit x tends to 0 plus mod x by x. This is limit x tends to 0 plus, here x goes to 0 from the right side of 0, so all x are positive, so mod x will give x, and this is x. So limit x tends to 0 plus of 1, that means 1, constant. The limit of a constant is that constant itself. So we see that left limit is minus 1, right limit is plus 1. So the limit x tends to 0, fx does not exist. The limit itself does not exist. So there is no question to continuous of this function at x equals to 0. That means the function is not continuous at the point x equals to 0. We see the next question. Our next question, question number 2. The function suppose 2 minus mod x by x when x not equals to 0, and this is 0 when x equals to 0. Suppose this is a function. Suppose whether the function fx continuous at the point x equals to 0. Actually, this function will not continuous, because if we find the limit, actually to continuous at the point x equals to 0, we have to show limit x tends to 0 fx equals to f of 0, that means 0. But here this limit does not exist, because limit x tends to 0 fx equals to limit x tends to 0 2 minus mod x by x equals to limit x tends to 0 2 minus limit x tends to 0 mod x by x. This limit does not exist, so this cannot happen. Hence the function is discontinuous at the point x equals to 0. Now our next question is, suppose a function is given by 3 plus 2x for minus 3 by 2 less than x less equals to 0. Sorry, this is less than 0. This is less than 0. This is less equals to 3 minus 2x for 0 less equals to x less than 3 by 2, and minus 3 minus 2x for x greater equals to 3 by 2. This is the question. We have to show that fx is continuous at x equals to 0 and discontinuous at the point x equals to 3 by 2. This is our question. Next question. Here limit for the first part, continuous, to check continuity at the point x equals to 0, we see the left limit x tends to 0 minus at the left of the 0, that means here the function is 3 plus 2x. The function is 3 plus 2x, and so this is 3 plus 2 into 0, this is 3. The right hand side limit, that is limit x tends to 0 plus of fx, this is limit x tends to 0 at the right of 0, the function is 3 minus 2x. This is 3 minus 2 into 0, that means 3. Now f of 0, here we see that left sided limit and right sided limit are equal. Hence from here we can say limit extends to 0 fx is exist and equal to 3. Now we see that what will be the value of f of 0. F of 0 means when x equals to 0. When x equals to 0, function is 3 minus 2x. That means 3 minus 2 into 0. When x equals to 0, the function is 3 minus 2x. Here f of 0, that means we are putting x equals to 0. That means we are putting x equals to 0 in 3 minus 2x. This comes 3. So limit extends to 0 fx. This is equals to f of 0. So fx is continuous at the point x equals to 0. Now we see the next part of this problem to show the discontinuity of the function at the point x equals to 3 by 2. Let's see. We will check here the existence of the limit extends to 3 by 2 of fx. For this, at first we will check the left limit and the right limit of fx. The left limit, in the left limit, limit extends to 3 by 2 minus, at the left of 3 by 2, function means 3 minus 2x. So this is 3 minus 2 into 3 by 2. This is 0. At the right side of 3 by 2, the function here, at the right side of 3 by 2, the function is minus 3 minus 2x. Minus 3 minus 2x, that means minus 3 minus 2 into 3 by 2. This is minus 3. Minus 3, this is minus 6. So the left limit is 0, and the right limit is minus 6. So these two limits are not equal, so the limit extends to 3 by 2, fx does not exist. So we cannot show that limit extends to 3 by 2, fx equals to f of 3 by 2. Cannot be shown. So the function is discontinuous at the point x equals to 3 by 2. We see the next problem. Our next problem is, suppose fx is defined as kx minus 3. Kx minus 3 when x less equals to 1, and this is 3x when x greater than 1. Now, this is saying that find k, find the value of k for which the function is continuous. For which the function is continuous at the point x equals to 1. We will find the value of k with respect to the condition that the function is continuous at the point x equals to 1. For this limit extends to 1. If we assume that fx is continuous at the point x equals to 1, then we can write that limit extends to 1 of fx equals to f of 1. F of 1 means, that means from here we can write limit extends to 1 minus fx equals to limit extends to 1 plus fx, and this is f of 1. Now limit extends to 1 minus fx equals to limit extends to 1 plus fx. This giving that limit extends to 1 minus, that is at the left of 1 when x is less than 1, left means less than, the function is kx minus 3, and limit extends to 1 plus, that means 1 plus means which are greater than 1. When x greater than 1, the function is 3x. So this is 3x. That means k into 1 minus 3 equals to 3 into 1. So k minus 3 equals to 3. So k equals to 6. Hence the required value of k is 6. Required value of k is 6. Now we will discuss some questions by graph. Now our next problem, check the continuity of the function fx equals to mod x at the point x equals to 0 without any calculation through limit. Without any calculation through limit. Okay, actually we will draw the graph of the function fx equals to mod x. From there we can easily see that the function is continuous at the point x equals to 0. If this is x-axis and this is y-axis, then the graph of the function fx equals to mod x is this. This is x equals to 0. This is x equals to 0. Here the function is continuous, the graph is continuous, so the function is continuous at the point x equals to 0. If you have given fx equals to mod x minus 1, suppose, what will be the continuity category at the point x equals to 1? The graph will be, this is suppose x equals to 1, then the graph will be this. Function is continuous at the point x equals to 1. Let's see our next problem. Our next problem, suppose fx is given as x square minus 16 by x minus 4 when x not equals to 4. Now you are asking that what will be the value of f of 4? What will be the value of f of 4 with respect to the condition that the function is continuous at the point x equals to 4. Fx is continuous at the point x equals to 4. Then what will be the value of f of 4? If function is continuous at x equals to 4, then we can write limit x tends to 4 fx equals to f of 4. Here the limiting value will be the value of f of 4. The limiting value of the function is x square minus 16 by x minus 4. Limit x tends to 4. X square minus 16, this is the formula a square minus b square. That means x square minus 4 square. That means x plus 4 into x minus 4. And this is x minus 4. So limit x tends to 4, x plus 4, this is 4 plus 4, this is 8. So the value of f of 4 equals to 8. Now I will give some homework. If you have any query or question, please comment in the inbox. Homework. Question number 1 is, suppose fx equals to kx plus 3 for x greater equals to 1 and 2x square for x less than 1. What will be the value of k if fx is continuous at the point x equals to 1? If fx is continuous at the point x equals to 1. The next question, suppose fx equals to minus x for x less than 0, 2 for x for 0 less than x, 0 is equals to x less than 2, and for x greater equals to 2 the function is 4 minus x. Check the continuity of the function at x equals to 2. The next problem, next question, suppose function is given by x square minus 1 by x cube minus 1 for x not equals to 1, then what will be the value of f of 1 if the function is continuous at the point x equals to 1. Our next question, suppose a function is given by x plus 1 when x less equals to 1 and 3 minus ax square when x greater than 1. Find the value of a if fx is continuous at x equals to 1. Okay. The next question, see the next question, we have already solved it. Suppose a function is given by fx equals to minus x for x less than 0, 0 for x equals to 0, and plus x for x greater than 0. Then whether the function fx is continuous at x equals to 0 or not. See that this function can be written as this function is nothing but mod x. This function is nothing but mod x. And the continuity of this function, the continuity of the function mod x have already checked at the point x equals to 0 in the previous problems. If you have any problem or query, please comment in the comment box. And if you have feels that this video will come in the improvement of your study, then please like and subscribe and also share. Thank you.